Welcome once again to my channel. In the previous video, we have seen what is clipper and its application and the types of the clipper circuits. Now, in this video, we will study that how a diode-based clipper can clip off the input waveform along with the method to solve any problem on the clippers. Starting with the series clippers. So let's start with the simplest case of the series clipper. And I am assuming that this diode is ideal one. So we need to find out the output waveform for a sinusoidal input. Now before finding the output waveform, you should know the two concepts. When a diode is forward biased, or you can say the diode is on, then we need to replace this diode with a closed switch, and if it is reverse biased, or you can say it is off, then it will be replaced with an open switch. Now as we have taken that the input is a sinusoidal waveform, so in the positive half cycle, what will happen? In the positive half, this diode will be forward biased and we can say the diode is on. So we replace the diode with this closed switch, the circuit will become, which means that output will follow the input. In the negative half of the input signal, the diode will remain off and output will be 0. Using this, let's draw the output waveform. So in the positive half, output is following the input, and in the negative half of the input signal, it will remain 0. Now let's draw the transfer function for this circuit. So when Vin is greater than 0, the output will be equals to the input, and when Vin is less than 0, negative, then output will be 0. This is the transfer function for the circuit. Now in the second example, अब आप इसका output waveform draw करिए, input को consider करिए एक sinusoidal signal के लिए. Difference सिर्फ इतना है कि diode के direction को reverse कर दिया है, and assume that diode is ideal. But what will happen if this diode is not ideal? This is practical one. Then whenever it is forward bias, we need to replace the diode with a voltage, and its value is equals to the cut-in or the threshold voltage. So in the third example, let's draw the output waveform when a diode is practical one. So when input signal is at its positive half, the diode will be on, it is forward biased, and we replace this diode with cut-in voltage और the threshold value. Voltage की direction depend करेगी कि आपका diode का P और N terminals किस side है. In the negative half, diode will remain off and the case will be same as we have seen in the first example. Let's draw the output for this case. तो सबसे पहला step होगा इसमें कि आपको input signal में एक voltage level को mark करना होगा, and इन points को आप correspondingly output की axis पे mark कर लीजिए. So when diode is on, the output voltage will be equals to the input minus cut-in voltage, which means that we will get output only when Vin is greater than the cut-in voltage, and diode will remain off when V input is less than the cut-in voltage. So जब आपका input voltage cut-in voltage से कम होगा, डायोड ऑफ होगा. जैसे ही इनपुट वोल्टेज की वैल्यू कट इन वोल्टेज से ज्यादा होगी, तब हमें आउटपुट मिलेगा. सो इसको हम ऐसे बनाएंगे. यहां पर फिर से कट इन वोल्टेज आ गई, तो अगेन इनपुट की वैल्यू डिक्रीज हो रही है कट इन से, इसलिए डायोड फिर से ऑफ हो जाएगा, एंड फॉर द नेगेटिव हाफ इट रिमेन्स ऑफ. सो दिस इज अ output waveform. Now let's draw the transfer function for this case. So here we will mark a cut-in voltage, and we will get output only when the input is greater than the cut-in voltage. Otherwise diode आपका off हो जाएगा. Till now we have seen the simplest cases of the clippers. Now I will tell you the steps to solve any clipper problem. But before that, if you are new to my channel, then please subscribe it and press the bell icon to get the notifications of all upcoming videos. Now let's see the simplest ever method to solve clipper problems. Now I will take an example of bias series clipper. Here I am assuming that this diode is ideal one. So first step में आपको ये देखना है इस सर्किट में टोटल वोल्टेज क्या है, V in minus of VR. And the next step, what will be the condition to this Vin minus VR so that diode will be on? इसका ये पॉइंट आपका P साइड है, ये N है. डायोड को फॉरवर्ड बायस करने के लिए Vin माइनस VR पॉजिटिव होना चाहिए, विच मीन्स दैट Vin शुड बी ग्रेटर देन VR. डायोड ऑन होने पर, क्योंकि ये आइडियल है तो हम इसको रिप्लेस करेंगे शॉर्ट सर्किट से, तो V आउटपुट की वैल्यू सिंपल Vin माइनस VR होगी. ओके, अब यहाँ पर आपको सिर्फ अपना सिंपल कॉमन सेंस यूज करना है. अगर डायोड ऑन होने की कंडीशन ये है कि Vin माइनस VR पॉजिटिव होना चाहिए, तो डायोड ऑफ होने की कंडीशन क्या होगी? ऑब्वियसली when Vin माइनस VR is less than 0 और Vin is लेस देन VR. तो यहाँ पर हम देख सकते हैं कि क्लिपर्स में सिंपल हमें ये कंडीशन फाइंड आउट करनी है कि कब हमारा डायोड ऑन होगा, और उसकी इनवर्स कंडीशन ऑब्वियसली डायोड ऑफ होने की होगी. लास्ट यहाँ पे हमें ये पॉइंट नोट करना है कि V इनपुट का हमारा कंपैरिजन किस वोल्टेज से हो रहा है, क्या पॉजिटिव रेफरेंस वोल्टेज से हो रहा है या फिर नेगेटिव रेफरेंस वोल्टेज से. यहाँ आप देख सकते हो कि Vin का कंपैरिजन पॉजिटिव रेफरेंस वोल्टेज से हो रहा है. तो जो हमें एक इनपुट वोल्टेज पे एक्सेस बना रही है वो पॉजिटिव साइड में बनानी है. नाउ लेट्स ड्रॉ द आउटपुट वेवफॉर्म. तो सबसे पहले हम एक्सेस को ड्रॉ करते हैं. नाउ Vin व्हेन इट इज ग्रेटर देन VR, देन ओनली वी आर गेटिंग V आउटपुट. सो हमारा जो भी इनपुट वोल्टेज VR से कम पर है वहां पे आउटपुट 0 है. तो यहाँ पर भी हमारा Vin जब हमारा VR से कम होगा तो हमारा V आउटपुट 0 होगा, अदरवाइज हमें V आउटपुट अवेलेबल होगा. सो वी विल गेट आउटपुट लाइक दिस, एंड द पीक ऑफ दिस वेव फॉर्म इज Vm minus VR. And obviously when Vin is negative, diode is off, so we are getting output 0. Dear learners, I am going to explain you every case of series and shunt clippers, so please watch it completely and thoroughly. Now let's see another example on bias series clipper. So this is the circuit. Here I just reversed the direction of the diode as you have seen in the example 4. Now again repeating the same steps. The first step is to find out the total voltage in the circuit. So what is the total voltage in the circuit? It is again Vin minus of VR. Now we need to find the condition from this total voltage, that what will be the condition to make this diode forward bias. So here diode will be on when Vin minus VR, this voltage is less than 0, because this side of the diode is N and this one is P. So if it is negative, then only the diode will be forward bias, which means that Vin should be less than VR. Otherwise, diode will be off. And when diode is on, the output voltage is simply the same Vin minus of VR. The diode will be off when Vin is greater than VR. Just reverse of this case. And when diode is off, V output will be 0. For the output waveform, we need to see that whether input is compared with positive reference voltage or the negative reference voltage. Axis should be at positive reference voltage. अब यहाँ पर आप ये देखिए कि जब रेफरेंस वोल्टेज से हमारा इनपुट ज़्यादा होगा, यानी ये पॉइंट, तो आउटपुट आपका 0 है. नाउ टू ड्रॉ द आउटपुट वेवफॉर्म फॉर द केस व्हेन Vin is less than VR, we need to find out the points using the boundary conditions of the circuits. For the boundary conditions, we have V output is Vin minus of VR. So first case, when Vin is equals to 0, then V output is negative of VR. And the second case, when Vin is minus of Vm, then V output is minus Vm minus VR. So when Vin is equals to 0, V output is minus of VR. तो आउटपुट वेवफॉर्म आपकी ऐसे ड्रॉ होगी. नाउ व्हेन Vin is minus of Vm, so V output is minus Vm minus VR. So this will be like this. and this is our V in minus VR. Now moving ahead, next example is, so this is our circuit. What is the total voltage in the circuit? It is V in plus VR. And the condition to make the diode on is V in should be greater than minus of VR. Now diode will be off when just reverse condition, V in is less than negative of reference voltage. Now here you can see that V in is compared with minus of reference voltage. So our axis will be minus of VR. Now let's draw the output waveform. For this case, since our axis is minus of VR, so we will mark a negative reference voltage at the negative side of the input waveform. Now this input voltage is more negative than the negative reference voltage. So our diode will be off and output will be 0. And the rest part of the input voltage is V in greater than minus of VR. To draw the output waveform for the case when V input is greater than negative reference voltage, we need to mark points using the boundary conditions. Now using these two conditions, and our output will be like this. And the maximum amplitude will be Vm plus Vr. Now let's see what will happen to the output waveform when we reverse the direction of the diode. So our next example is, इस केस में हमने डायोड के डायरेक्शन को रिवर्स कर दिया है, तो V in प्लस VR जो हमारी टोटल वोल्टेज है ये नेगेटिव होनी चाहिए, बिकॉज दिस साइड इज N, दिस साइड इज P, which means V in should be less than minus of VR to make the diode on. And इसके रिवर्स आपका कंडीशन होगा डायोड ऑफ करने के लिए, विच मीन्स दैट V in should be greater than minus of VR. अपनी कंपैरिजन एक्सिस क्या होगी? Minus of VR. Dear learners, here you should note a very important point. When we are saying that V in is greater than minus of VR, whatever the value of V input which is less negative than minus of VR. And if we are saying that V input is less than minus of VR, it means V input is more negative than the minus VR. तो आप ये देखिए कि V इनपुट की ये जो वैल्यू है ये लेस नेगेटिव है देन माइनस ऑफ VR. सो इसको हम कहेंगे V in ग्रेटर देन माइनस ऑफ VR. And when V in is greater than minus of VR, our diode is off. So output will be 0. और ये जो वैल्यू है नेगेटिव VR के बाद में इनपुट की वैल्यू ये मोर नेगेटिव है देन माइनस ऑफ VR. सो दिस इज आवर केस व्हेन V in is लेस देन माइनस ऑफ VR. और इस केस में हमारा डायोड ऑन है तो आउटपुट हमारा हो जाएगा ये. So up to this point I have explained every case of series clippers. Now let's see the shunt clippers. Dear learners, I have seen many videos where the presenters assure to give tricks to solve clipper problem just by looking into the circuit. But those tricks are not applicable for every clippers. So be careful, and it's always better to use the concepts with logical reasoning to solve any problem. It is just a simple concept to know whether when the diode is on or off. Here, when V input is positive, diode will be on, and we will replace this diode with closed circuit. And when V input is at its negative half of cycle, then diode is off, and we'll replace it with the open circuit. So for this circuit, the output waveform will be, so we will get 0 output when input is at its positive half cycle, and output will follow the input in the negative half. See, this is very simple. So now find the output waveform for this circuit. You can take any alternating waveform like sinusoidal or the square waveform. It doesn't matter. The concept will be same. Now let's see examples of the biased shunt clippers. So concept हमारा same है. So diode will be on when Vin minus VR is positive because this side is P side of the diode. When diode is on, this diode will become short circuit. So output will be constant at VR and diode will be off. Just exact reverse condition होगी V in less than VR की. When diode is off, then V output will follow the input. So what is the comparison axis? Comparison axis is VR. Now let's draw the output waveform. So जब Vin की वैल्यू VR से कम होगी, ये पॉइंट देखिए Vin इंक्रीज करना शुरू किया, Vin की वैल्यू VR से कम है तो V आउटपुट आपका Vin को फॉलो कर रहा है. तो यहाँ पर हम V आउटपुट को इंक्रीज करेंगे जस्ट एग्जैक्टली लाइक इनपुट. जैसे ही VR पे वैल्यू आएगी तो ये कांस्टेंट हो जाएगा. अब ये इंक्रीज नहीं करेगा, अब इसकी वैल्यू कांस्टेंट हो जाएगी रेफरेंस वोल्टेज पे. तो आउटपुट की वैल्यू कांस्टेंट हो गई. वंस अगेन जैसे ही Vin की वैल्यू डिक्रीज होना शुरू होगी, आउटपुट इनपुट को फॉलो करने लगेगा. तो आउटपुट इधर आएगा, इनपुट को फॉलो कर रहा है एंड रेस्ट पार्ट में भी ये इनपुट को फॉलो करेगा. So this is our output waveform for the circuit. So using the same method, draw the output waveform for this circuit. Now moving ahead, the next example is, so as you can see in this circuit, the total voltage will be V in plus VR. And to make the diode forward bias, V in plus VR should be positive or V in should be greater than minus of VR. And diode will be off when exactly reverse situation, V in less than minus of VR. Here comparison axis is negative of VR. So here you can see that minus VR से ऊपर जितना भी वोल्टेज है इनपुट का, वो आपका केस है डायोड ऑन होने की. उस केस में V आउटपुट जो है वो कांस्टेंट हो रहा है minus VR पे. That's why I have marked this minus VR in the output waveform also. From this point to this point, here output is constant at minus of VR. And when V input is लेस देन माइनस वी आर, ये जो हमारी इनपुट वोल्टेज है जो कि मोर नेगेटिव है माइनस वी आर से, इस केस में डायोड ऑफ होगा और इनपुट को फॉलो करेगा. सो इनपुट को फॉलो करेगा, दैट्स व्हाई दिस इज आवर आउटपुट वेवफॉर्म. सिंपल इसी कॉन्सेप्ट से आप नेक्स्ट एग्जाम्पल के भी आउटपुट वेवफॉर्म को ड्रॉ करिए. So up to this point, I have explained you every case of series and shunt clippers. Now let's see examples of double-ended clippers. So this is a double-ended clipper. In this circuit, as you can see that there are two diodes both connected in the reverse direction and biased with voltages V1 and V2. For this circuit, I am assuming that V1 is greater than V2. Now let's see how we can find out the waveform for this circuit. So the method will be same. First we will solve for this D1 diode. So D1 will be on when V in minus of V1 is greater than 0, because as you can see the diode D1, the positive terminal is connected to the node. So this V in minus V1 should be greater than 0 or V in should be greater than V1. This is our first condition. And when this D1 diode is on, then output will be constant at V1 voltage. Similarly, the D2 diode will be on when V input minus of V2 is negative. See, the negative terminal of the diode is connected to the node. V in is less than V2, then D2 will be on and output voltage will be constant at V2. So let's draw the output waveform for double-ended clipper. This is very simple. So what is our comparison axis? Here we have two comparison axes. The first one is the V1 and the second one is V2. Since V1 is greater than V2, so first I am marking V1 and then V2. Now when V input is less than V2, here you can see this part is V input less than V2. Then output is constant at V2. So output is this. Once again, here also, so output is constant at V2. Next point is from this to this, Vin is greater than V1. So V output will be constant at V1. So making V output which is constant at the value V1. So in between V1 to V2, the output will follow the input. So this is our output waveform. Now let's see another example of the double-ended clipper. So D1 diode को on करने की condition क्या होगी? V input minus of V1 should be positive and D2 diode को on करने की condition क्या होगी? Look into this mesh. So V in plus V2, it should be less than 0. So here our comparison axis will be positive of V1 and minus of V2. So when Vin is greater than V1, the output will be constant at V1 और जो Vin की value more negative होगी minus V2 से, which means this is Vin less than minus of V2. At this point, V output will be constant at minus of V2. आउटपुट वोल्टेज कांस्टेंट हो जाएगा V2 पर. रेस्ट पार्ट में V आउटपुट Vin को फॉलो करेगा. That's why output will be like this. So this is the output waveform. So this is all about the diode based clippers, and do not forget to keep practicing. I hope you like this video, so please subscribe my channel and share it. If you have any queries regarding this topic or any other topic of analog electronic circuits, you can write me in the comment section. And also you can mail me your feedback. Your feedback is very valuable for me. Thank you for watching. Have a nice day.